welcome on behalf of the department at NC State. If you're from outside, it's a real pleasure and a privilege to have you here. I would like to start by thanking Fidelity Investments and particularly the Technology Group for supporting this event. It is the fourth year of this event, the series, and it is really outstanding, and it is in very, very large part thanks to you actually showing up and coming and being here. Of course, the speakers are outstanding. And today, I have the privilege to actually introduce Mr. Michael Tiemann. He's the Vice President of Open Source Affairs at Red Hat. And Michael, I'm sure you all know him, whether you know that or not, because we teach C++. And we do that primarily on Linux boxes. And he is one of the authors. In fact, he's the author of the GNU C++. And so whether you know it or not, you have known him for some time now. So this is really a true pleasure and a privilege to have him here. In 1989, Michael essentially understood the open source model and created Cygnus Solutions, which was one of the first companies to actually make money out of open source. And if you don't know what the model is like, it's a very interesting model, and maybe Michael will mention that today as he talks about it. And the company was acquired by Red Hat in 2000, and he became Red Hat's CTO, Chief Technical Officer, or Technology Officer, and later he became the Red Hat's first Vice President of Open Source Affairs. He serves on a number of boards, including Open Source Initiative, and supports organizations that further the goals of software and programmer freedom, including Free Software Foundation and the Electronic Frontier Foundation. He is a visiting scholar at the School of Information and Library Sciences at UNC Chapel Hill and was the founding member of the Board of Advisors for the Center for Environmental Farming Systems. And in addition, Michael has remained active in the Creative Commons community as both a sponsor of projects and promoter of the cause. Michael has graduated from the Moore School at the University of Pennsylvania with a BS in CSE, and later he did research in Riyadh, that's in France, and at Stanford University. So please help me welcome Michael.
So we need some gain. Let me put this at minus 10 dB and see if that's better. Check. How's that? Can you guys hear me in the room? Fantastic. So one of the great privileges I have as Vice President of Open Source Affairs is I get to travel the world and talk with executives in the public and private sector about open source software, strategy, policy, and technology. And it's been a great honor to meet. I've actually met the Brazilian president. I've met ministers of finance, education, science, and technology, many different countries. But there's something very special about coming and giving a talk at NCSU. And that is that with my Red Hat badge, I know where I'm going to park. So I'm going to talk tonight about competition and sustainability, two sides of the same coin. And I'm going to sort of try and gauge whether to stay conservative in comporting with the Fidelity Investments sponsorship, or get a little bit more radical in terms of the analogies that I use and the directions that I go. So I may go a little off script if you look interested, and I'll stay on the script if you look really bored. Because I'll assume if you're looking really bored, it's because you don't understand. So anyway, so look interested, and I'll keep going until you start looking lost again, and then I'll tone it down. So, dear me, we have a little overscan problem. Let me see if I can, wonder if there's a good way to fix that. I don't know. Well, I'll tell you what. We'll just, we'll figure out the slides later. So, in my travels, one of the things that I have is an opportunity to read a lot of books. And when I was in high school, one of the reading assignments I blew off was reading Alexis de Tocqueville's Democracy in America. And I always felt guilty about that. And I really felt guilty about that when I was on some long trip to Asia. And I thought, well, I'll just pick up a copy and read it. And I really delighted in it. Over the course of American history, it has been sort of, the moral equivalent of the top Oprah book pick of the month, for various generations, and at other times it's been relatively unknown. But I really felt the need to reconnect with the concept of democracy in America when I was afraid that we might be losing it. So anyway, I came across this wonderful quote that talks about the origin of innovation in America. De Tocqueville wrote this in 1835, and what he observed was that when a private individual mediates an undertaking in America, however directly connected it may be with the welfare of society, he never thinks of asking permission of the state, but instead he publishes his plans, offers to execute it himself, struggles against all obstacles, and is undoubtedly less successful than the state would have been had the state undertaken it. However, the sum of all these private undertakings far exceed what the state could possibly do. And the reason I found that such a wonderful line is because that basically encapsulates what my own entrepreneurial experience was. I came across open source software in school in 1985. Richard Stallman had just published GNU Emacs, and I was hungry to look at what real source code looked like, having written my fair share of pseudocode. And it was really exciting to me to see not 100 lines or 1,000 lines of source code, but 10,000 lines of source code, 100,000 lines of source code. And I was really amazed at the poetry of the code, the functionality of the code, the opportunities that presented in terms of modifying the code. And it seemed a heck of a lot better than what vendors were shipping at the time. And I started agitating with this idea that open source software might be better than proprietary software. And when people would sort of compare it apples to apples, they would say, well, yeah, it's better, but you can't make money with free software. And I heard that for 2 years until, and after hearing that so consistently, of course it's better, but you can't make any money. I realized that my key competitive insight was if everybody thinks that it's better than the alternatives, it probably is. And if nobody thinks I'm going to make any money, I'll have no competition. And it was that insight that gave me the courage to say, all right, I'll try this. So are we backwards or forwards? Okay, excellent. So, so anyway, let me just bring you back to my little world. When I was sitting in a chair like that at Stanford University, getting a compiler to a new chip cost between $1.5 and $5 million. It took 2 to 3 years to do. And at that time, National Semiconductor had offered a microprocessor that was trying to compete with the Motorola 68000. That was the original Apple Macintosh CPU. It was a full 32-bit architecture. It was nice and orthogonal like a VAX. It was advertised as a true 1 MIP performance. However, when it was delivered, it was only 3/4 of a MIP. And the day the GCC was released, I undertook to port it to this new chip. 2 weeks later, I had 20% better performance than the vendor compiler. And 2 weeks after that, I had 40% better performance. And here's something remarkable. If you do the math, 40% better than 0.75 is a true 1 MIP processor. But the folks from National could not be bothered to believe that this free software was better than the $5 million they spent on something that missed their performance goals, and National ended up exiting the microprocessor business. At that time, Los Alamos was busy buying workstations from Sun Microsystems. They made a single purchase of $100 million to go build a virtual atomic bomb. And when they were visiting my lab, I was working for a software company in Austin, a research consortium actually in Austin, Texas. They visited our lab, and I said, you tell me what's the most important mathematical routine in your codes, and let me take a crack at putting it through my compiler. Now, they were using the Sun Floating Point Accelerator, which is a proprietary chip with an instruction set that was not published. And I said, that's okay, we'll just look at the assembly code that comes out of the Sun compiler, and then I'll just sort of I'll infer the architecture, and then I'll see if all of our optimizations can actually generate better code. 4 hours later, I delivered 10% better performance, which if you think of a $100 million purchase, means that that generated $10 million worth of value, with 4 hours worth of effort. That was one of the things that began to make me think that there might be an interesting business model in there. Now, a month after that Los Alamos visit, I received a mysterious package by FedEx. And the mysterious package was an architecture manual for the Spark microprocessor. No idea who sent it, no return address, but I couldn't wait to read it. And I couldn't wait to port my compiler to it. And I began the port on a Friday night, and I finished it on a Sunday afternoon. And as I was watching those regression tests all cranking and working, it dawned on me who might have sent this package. A vice president from Sun Microsystems. So on Monday morning, called him up, said, I figured it out. Here's your performance benchmark. And he offered me a job on the spot, but I had prior commitments to the US government, which I fulfilled. Now also at that time, in 1987, that was the world's first Usenix C++ conference. We had about 50 people in the world come to the first C++ conference at the time. And Bjarne Strostrup, you all know, created the C++ language, and he's received a lot of recognition for his work. He's recognized by Fortune magazine, won the Grace Hopper Award, that's a big one. 20 most influential people in the computer industry in the last 20 years, that's a pretty good one. AT&T Fellow, that pays. Member of the National Academy of Engineering, my dad was one of those, that's a big deal. IEEE Fellow, my dad was also one of those, that's also a big deal. But he did not write a native code C++ compiler because, as he told me, it was too hard. Now, anyway, even Apple today is using GNU C++. But the real question here is this really about me or is this about free software? Now, if you read Malcolm Gladwell's book, Outliers, which I highly recommend, Gladwell looks at the question of, you find something really exceptional and you ask yourself the question, is the world better understood by ignoring the exception? Right? I mean, there's a lot of people who are looking at global climate change and saying, you know what, the world makes a lot more sense if you just ignore all that noise coming in from the Weather Service. Right? That's the concept of ignoring an outlier. Or is the world better understood by actually asking the question, how did that come to be? That's the outlier question. And then, or is it not me? Is it actually free software? Now, if you really read the Outliers book, you'll know that Gladwell says, you know what, it's not the individual. It's the context. It is the community. In fact, today on WUNC, Dick Gordon interviewed some Stanford students who put together a system called Steam Tunnels in 1999. It was Facebook before Facebook existed. They actually scanned all the Stanford Facebook on, into a system and began giving people connections, just like you saw in The Social Network if you saw that movie. And Stanford shut it down and said, this is horrible. Now, of course, if you saw the movie, Harvard tried to shut it down, but Zuckerberg wasn't paying attention. But the point is, the point is that these, whether or not something takes root is much more a function of the field than it is of the seed. And so keep that in mind as we move toward sustainability. So I believed that the success that I had witnessed coming in my own experience was really because of the freedom that was intrinsic to the software. If you've read the GNU General Public License, you know that it is loud and proud about the idea that programmers should have freedom and programmers should share that freedom with others to build community. And so my first understanding of this free software movement was that one could build a successful company on top of this concept of freedom. But that wasn't the whole story. And just as a little follow-on, Among the many different things that we did way back then, I know that now it's 2010, so all this stuff sounds pretty obvious, but I kid you not, when we put Cygnus.com on the internet and began offering commercial services mediated by an internet connection, I had to answer hundreds of times whether this was a legitimate purpose for the internet, which was seen by many to be just a research project. We created the world's first ISP called The Little Garden because we needed an internet connection. We invented the software subscription model. We invented the first free software publication, working POSIX environment for Windows, dual licensing model for open and proprietary software, all kinds of tools, put the Christmas tree online and made the front page of the New York Times, and of course the first open source company. At about that time, a guy named Tim Berners-Lee was doing something pretty radical. He used a really, really big name to describe something really, really simple. He put out this thing called the World Wide Web. And I remember when one of my colleagues downloaded that software, back when the web was just 3 computers. That's how close to the front we were. And we were all laughing at this idea that this thing could be called the World Wide Web. But what Tim Berners-Lee understood was that if you want to make something universal, you cannot maintain control. And we agreed with that. We recognized the sort of the genius that you have to cede control if you want things to grow. So that's another idea to keep in mind as we talk about this subject of sustainability. Now, I'm talking to you as Vice President of Open Source at Red Hat. I'm Source Affairs at Red Hat. I am not talking to you as Vice President or founder of Cygnus Solutions. Why is that? Well, there's really a couple of reasons. One is, in 1995, some friends of mine in Silicon Valley said, there's this company in North Carolina doing amazing things with a Linux distribution. You ought to go buy them. So I got my 2 co-founders together, both very smart people, and I made the case about why we should acquire a Linux distribution company that had virtually no revenues, that had technical qualifications that were questionable at best, and a bunch of other things that didn't seem to make any sense. But I said, you know what, I think there's something to this. And we were a multi-million-dollar profitable tools business doing multi-$100,000 contracts with big companies in the Valley. And I could not convince my co-founders to take 10% of our equity and buy Red Hat. 5 years later, they took 10% of their equity and bought us. And I'm going to do my best to sort of explain how that happened. So it's not just the Rally is a great place to be. This is a little chart. We will be finishing our latest fiscal year at the end of this month. And when we report those earnings, we'll see some other curve on the graph. But in the meantime, this is the latest annual data that we have published. And one thing that you could ask, you could look at these numbers from 2006 to 2010, and you could ask the very obvious question, what recession? Right. Red Hat's been doing a very good job of growing its business. And one of the ways that we do this, the mechanism that we use is we have, I was explaining this actually to the civilian equivalent to a 4-star general at the US Air Force last week. We have a model that looks an awful lot like a transformer with a primary and a secondary coil. And the primary coil interfaces to a community of tens of thousands of developers who are all doing little tiny things. And then the primary coil hooks into the 1,000+ engineers that we have at Red Hat and cranks that heavy coil into building an enterprise-class distribution that runs the New York Stock Exchange, the National Security Agency, the Tokyo Stock Exchange, whitehouse.gov, et cetera. And so what this slide diagrams in the blue is how our Fedora process engages the community, and it describes the various steps that we take in terms of looking at the suitability of software for inclusion into the Fedora distribution, the process of testing and packaging and interoperability, et cetera, and this idea of coming up with a new release 2 times per year, which I know you guys have a semester twice a year, but what we have found is that in our software development process, the rate of adaptation and innovation follows a seasonality of approximately every 6 months. We have tried making that a little bit longer, and it's a little bit like holding on to fruit a little too long. It starts to rot, before you can really enjoy it. And we've also attempted to shorten it up, and it very much has the feeling of fruit that was not given enough time to ripen. It's a little bit too hard. So we have found this rhythm that the world operates on, and that rhythm is way, way, way faster than any enterprise company wants to consume technology. Enterprises want to go really slowly, and so what this transformer does is it builds a mediation between how the community wants to work and how the commercial world wants to work. Ever since I've been at Red Hat, I've watched a graph like this get published that basically says who has been contributing to Linux. And here we see a number that's been consistent for about 10 years, which is none of the above is the largest contributor to, to the Linux kernel. But Red Hat is the largest named contributor. We have been ever since I've been there. And it might not be a big surprise that Red Hat contributes more than Novell because we do a lot more business than Novell. And it might be not that much of a surprise that we do more than, say, IBM or Intel, because IBM and Intel are focused on hardware, or they're focused on other kinds of things. It's pretty amazing to me, though, to find Google, down here with basically, they just missed the cutoff of being part of none of the above, and they've been there for actually 5 years. So Red Hat takes very seriously this concept of being engaged in the community. And the question to pose, just like I posed the question, is it about, was it about me or is it about free software? Is this really about Red Hat or is it really about the community? Red Hat is very proud of the fact that for 7 years in a row, we've been, number 1 or number 2 in enterprise in the assessment of CIOs about the value that we deliver to our customers. And I believe that it's not just about community, but it's also about a liberal distribution that we do. It's about that engagement with the community that really, really matters. I came across this book in 2005, and I wish I had taken its investment advice. The Only Sustainable Edge was written by John Hagel, who's a McKinsey consultant, and John Seeley Brown, who's the former director of Xerox PARC and CTO of Xerox. And they said a bunch of things that were very insightful. Number 1, they said that the business community has it wrong, completely wrong, when they think the world can best be described as a zero-sum game. Now, that was something which I actually recognized in the 1980s. We don't, on a human scale, we don't live in a zero-sum world. There is a positive energy flux of, I think the number is 20 petawatts per year of solar energy that washes across the Earth every year, right? That's free energy, some of which is converted into food, some of which is converted into heat, some of which is converted into other, good things. But that represents a charge which we are free to do something with. Now, they argue that, that the world is better described as a positive-sum game, and they make a lot of really, really good arguments. And they say that one of the reasons that the world has such a wrong concept of whether it's zero-sum or not is because politics is a zero-sum game. You can't be president without knocking somebody else out. But the business community is not like that. One person can be a retailer, and another person can be a manufacturer, and another person can be in services. And there's a lot of room for a lot of people in the business community if they learn the lessons of this book. And the lessons of the book basically state that there is far more business to be done growing the edge of the business and growing the relationships that the business has with what's outside the business than focusing on so-called core competencies. And what was really remarkable to me was that this book did not mention open source software at all, and yet every chapter really explains very, very well the open source thesis and why the open source thesis is so sustainable and so competitive. Now you're probably wondering, what business advice did this, or what financial advice did this book offer? They put forward this thesis that in the last 75 years, the highest paid CEOs of all the biggest companies in America have basically been accelerating the rate at which they destroy intrinsic value. They say that companies are working harder than ever to deliver less value than ever. And they point to a whole lot of different ways that you can measure this. And the one measurement that did not agree with their data was the financial services industry. And in 2005, they said, you know what? We think that is a statistical anomaly. It's an outlier. And we are so confident of our hypothesis that we would prefer to imagine that the financial services community is actually lying about their data than that we should accommodate what they're telling us into the model. Had I known that, I could have made a lot of money on a big short. So what about this sustainable edge? In 2002, Eric von Hippel, who has made his career on user-driven innovation, published an article in the Harvard Business Review about how Jack Welch became chairman and CEO of General Electric. He obviously wasn't born into that role. He was actually my dad's boss at GE in Schenectady as head of R&D for some period of time. But he was, GE has this farm system where if you do a good enough job in one position, they'll just keep moving you up until you fail. And so they took him out of research and development and they made him manager of GE Plastics. So GE Plastics used to function what you see to your left, to my right, which is that they had a whole bunch of smart people in advanced development designing and building polymers that basically define the universe of what could a GE plastic be. And they had a team of people who would design products, a team of people who would figure out how to operationalize those designs, and then they'd take those plastics to customers and say, what do you think? And the customer might say, oh, that's very interesting. Can you make it bulletproof? So it would go back up to design, and they'd figure out how to do that. And it would come down, they'd figure out how to build it, and then they'd show off this new product. And they'd go, wow, can you make it clear? And they'd go back up to design, and then they'd figure it out and go down to build. And they'd say, look. And the customer would go, wow, can you make it float? And it would go through that cycle a number of times. That was an expensive cycle. All of GE's capital risk is borne by GE until the customer finally says, wow, I'm going to buy it. And Jack Welch said, boy, is that a dumb way to do business. How about instead we maintain our capability of development, but what if we gave the customer the tools they needed to be able to do design? And what if they could build a virtual prototype with this toolkit and test the suitability of this virtual design themselves, and if they decide they want to do something different, they can change the design parameters. And a whole bunch of amazing things happened as a result of this, because first of all, the language of the customer's needs and the language of the customer's goals don't always translate into the language of the vendor and the supplier. So all of a sudden now, the customer has a closed loop between their, what they're seeing and what they're wanting, and they learn by doing. They begin to learn for themselves what it is they're actually looking for and when something is good enough. And what basically happened in the blink of an eye at GE Plastics was that they became more profitable, they became more agile. Think about this. If you are if you're a business line manager, there's a finite book of products that you can manage. You all know about the 80-20 rule, and you try and focus all your efforts on the stuff that really makes you money. Well, if GE tries to figure out what's the most important subset of what their most important customers want, you have a whole lot of customers who have a whole lot of dissatisfaction. Over in the customer-driven innovation world, it is the customers themselves who manage that portfolio and decide what they care about and see that it's well served. And so, even if you've got a crazy great product portfolio manager working at GE who can handle 10,000 products, boy, if you've got 10,000 customers, that's a pretty thin design book as far as they're concerned. But in the customer-driven innovation model, you can basically scale it to any proportion. And so the result is that GE dramatically increased their total available market. They dramatically accelerated revenues, profitability, customer satisfaction, you name it. And people were so impressed that they said they gave Jack Welch the keys to the business. But this is not a new story. This graph, a graduate student put together, and what they measured was the reported efficiency of Cornish steam engines. So I'm going to walk way over here. Back in 1775, James Watt applied for a patent on the steam engine. Now, in 1775, there was no patent office. The way you got a patent was an act of parliament. You've probably heard the expression, that would take an act of parliament. That took an act of parliament. Now, he convinced parliament that giving him the monopoly permission to produce steam engines for the whole kingdom, that his diligence and his investment and his returns would guarantee the best possible outcome for society. So they gave him a patent, they gave him 25 years of exclusivity, and James Watt took a steam engine from 6% efficiency up to about 20% efficiency. As the expiration date of that patent approached, he went back to Parliament and he said, I need a new patent. And they said, do tell. He had become very rich, become very famous, very successful. And James Watt said, if I don't get an extension on this patent, the Industrial Revolution as we know it will cease to exist. Now, back then, the lawmakers were maybe not quite so beholden to special interests, and they said, que sera, sera. They let the patent expire in 1800, and a whole bunch of people began entering the steam engine R&D business, and they started publishing results, and you can see that the Industrial Revolution that James Watt knew did in fact change dramatically as steam engines became substantially more efficient, but not just more efficient. James Watt used to manage his steam engines the way that IBM actually didn't sell, mainframes. James Watt would lease steam engines to only a few select businesses that he deemed reasonable. So he lent them to steel and coal mining industries, but not a whole lot else. This second industrial revolution, and if you don't believe me, you can read about it on Wikipedia. The second industrial revolution was all about adapting motive power to all kinds of different activities: agriculture, manufacturing, textiles, small-scale factories, etc. And I know you guys are probably dying to know. You can't really quite read this graph, but this is 1800, 1820, 1840. I can't even read it. But anyway, this steepest part of the curve right here, that's when Alexis de Tocqueville was publishing The Origin of Innovation in America in 1835. Alexis de Tocqueville was observing this meteoric rise of capability in America. And in fact, the second industrial revolution did not belong to Britain. It belonged to America because we were sufficiently disorganized to do a lot of different things. Now, the reason that we saw that peak in 1845 is because no longer only a mining tool. Remember, these steam engines used to blow up all the time. When they were used in mines, they would kill miners. When they were later used in factories, they would kill factory workers. in the 1840s, they began building locomotives. When those steam engines blew up, they would kill customers. And the business community treated that third case very differently than the way they treated those first two cases. And as a result, this single dimension of quality, namely efficiency, does not properly report later improvements on serviceability, reliability, maintainability, mobility, terms which you often hear enterprise software vendors talking about all the time, but it also applies to steam power. Now, I told you that it's not just about community, I'm learning. It's also about the way that you engage with that community and this concept of liberal distribution. And a professor at Berkeley, at UC Berkeley, came up with the following insight, which is that the conventional and legal concept of property is the right to exclude. When you own property, you can stop other people from accessing it, you can stop other people from using it. That's really what the right of property is. And yet, in the world of open source, the rights that we exercise are the rights to modify, and more importantly, the rights to distribute. And it's that right of distribution, as different from the right of ownership, that I think makes all the difference. And believe it or not, I'm not the only one. After Red Hat turned us down, us being Cygnus, I read this in Fortune magazine and I slapped my head and I said, this was the business case for buying Red Hat. In 1995, Andy Grove explained, Gordon Moore explained the following about Intel. The whole point of integrated circuits is to absorb the functions of what were previously discrete electronic components, integrate them into a single new chip, and then give them back for free. That's liberal distribution, by the way. Or at least a lot less money than what they cost as individual parts. Thus, semiconductor technology eats everything, and people who oppose it get trampled. This idea that when certain costs can be dropped to zero, and thereby one can create an infinite distribution, this takes us to a place in the economic textbooks where the text has not yet been written. There's a, if NC State wants to become a real leader in the teaching of economics, I would argue that a rigorous and complete explanation of what happens when cost goes to zero, as it does in so many dimensions in the information society, those are often treated as anomalies in a world of physical property, but in semiconductor technology, in software technology, we see free every day. So how then does this relate to sustainability? Well, we can look at sustainability from a relatively simple perspective, and that is, does doing more of something actually help or hurt? If doing more of something helps, then it's going to be sustainable. It's a positive reinforcement. If doing more of something actually diminishes the resource, it's ultimately not sustainable. And the number of different stories of sustainable versus unsustainable approaches is really quite remarkable. I came across this lovely gem called Unlocking the Sky by Seth Schulman. It's fascinating. The Wright brothers really not only, the Wright brothers undertook after their famous flight, they really undertook to literally rewrite history. And this book chronicles how they threatened and coerced the Smithsonian to write history in a way that was more favorable to them if they wanted to get a copy of the Wright Flyer. Now, what this book presents is that when you actually look at the design of the Wright aircraft, almost everything about it is wrong, except it does fly. When you look at a modern aircraft today, you can find 500 different inventions that Glenn Curtiss came up with and, as a hobbyist and a tinkerer, gave to the industry. And the Wrights ran around trying to shut him down. They sued everybody for, they got a patent on controlled flight. It's a pretty broad subject area. And anybody who practiced that patent, the rights would say, you're controlling flight, you owe us a royalty. I visited the Wright Memorial in Kitty Hawk, and sure enough, there are over 100 portraits on the wall. Amelia Earhart, Langley, all kinds of famous people you may or may not have heard of, Saint-Antoine d'Exupéry, etc. There's not a picture of Glenn Curtiss, who literally did give us the modern aircraft. Now, in the world of software, it's just about as bad. The way in which software is presently constructed is much more concerned with maintaining a competitive, or some would actually argue and have in court, an anti-competitive position. And what David Bank, a reporter for the Wall Street Journal, wrote about when he chronicled Microsoft's maneuvers, time and time again, Microsoft preferred to injure their customers as much as necessary in order to more injure their competition. And the consequence of this bad behavior has been mounting costs and losses, one of which is has been, so far, no Moore's law for software. In fact, there's a new quote on Wikipedia attributed to Nicholas Wirth, which is that software is getting slower faster than hardware is getting faster. And that's really remarkable because Moore's law promises an exponential increase in semiconductor technology price performance every 18 to 24 months. Disk law promises that same doubling every 12 to 18 months. Fiber law promises network bandwidth to be doubling every 9 to 12 months. And how that triple exponential equation, can't keep up with the software is just absolutely crazy. And in fact, it's so crazy that when we look at the cost to the industry, it's just absolutely staggering. So I agree with Einstein on this one fact, which is we can't solve problems by using the same kind of thinking we used when we created them. And we have created quite some problems in software. We spend $1.3 trillion a year on enterprise software IT. 18% of our projects are abandoned before they go into production. 55% are late, lacking key functionality, or broken. $500 billion a year is wasted, is written off due to bad software. And people don't just spend money on IT just for fun, it's to deliver value. And that, generally speaking, people expect to get $6 to $8 of return on investment for every dollar they spend on IT. So if you're blowing away $500 billion a year in IT investments, you're losing $3.5 trillion in value. And in this day and age, every $1 trillion counts, right? So 3.5, that's 3.5 big ones. It is a growing consensus that the proprietary software model is not sustainable and that open source is a new approach that can address this problem. Now, to really look at how to reform an industry, I went back to Deming, who basically formulated a recipe for success for manufacturing. Now, he did not succeed in getting any Americans to listen to him the first time around. In fact, he was so unsuccessful in getting people to pay attention to him that he ultimately accepted an appointment by General Douglas MacArthur to go take his ideas to Japan. Now imagine it's 1950, right, which was a long time ago. Japan was not that easy to get to. But in any event, he took his ideas to Japan. He reports in his autobiography that the only reason that the Japanese did not tell him no, which every American did, was because they were too polite. So they adopted his principles, they adopted his philosophy, and his promise to them was that if you follow this way, you will create a world-class manufacturing capability within 5 years. And to his surprise, not only did they follow him, but they actually did it in 4. Now, the American mainstream press did not pick up on this in the 50s, nor the 60s. They only began even thinking about it in the 70s. And by the 1980s, as many of you may know, American industry was wildly uncompetitive with the quality that was coming out of Japan. This concept, for example, of improving a product and service constantly and forever, to me, that is a real signal of sustainability. If you can imagine how something can be better constantly and forever, you are talking about an equation of sustainability. If, on the other hand, you think that it's good enough and then you stop, now, first of all, that's not a very sustainable position. And second of all, pity the customer who has to accept that your definition of good enough is good enough. So let me get into this. So here is a graph from a paper published by Jim Herbsleb, Roy Fielding, and Andrew Marcus. It was Paper of the Year by the ACM Software Engineering Group in 2000. And it was most influential paper of the decade in 2010. They did a retrospective, and this was the most referenced software engineering paper. What they looked at was the difference, the observable difference between proprietary software and open source software. And what this graph shows is if you were to collect all the lines, you look at a software project, look at how many lines of code are changed, how many lines of code are added, how many lines of code are deleted, add all that up. The person who does the most of everything, we call that person developer number one. I was developer number one on the GNU C++ compiler way back when. And I did about 20% of everything, even when there were lots of people working on that compiler. It felt really good. Now, if software followed industrial logic, which if you've read the Mythical Man Month, you know it does not. But if it did, how many people would you need to do any software project according to this graph? There's got to be an engineer here somewhere. Call it out. 5 is correct. However, when you look at what do 5 people on the Apache project do, they don't do 100%. They do about 40% of the project. And in fact, in the case of Apache, they don't reach that 100% goal until 388 people have done something. If you look at a proprietary software project, you don't see that at all. You do see developer number one doing 20% of everything. You do see the first 5 developers doing about 40%. You do see 10 to 15 people doing about 80 to 90%. But in the proprietary world, you don't see hundreds of other people participating to make it better. You see another handful, the JV, who are waiting for the for developer number one to get married, or developer number 5 to have kids, or something like that. So, but the big difference is, think about things from the position of developer number 388. That's who I have become. I'm no longer a superstar hacker checking in lots of changes of code. I make a change once or twice a year. And having the freedom to make that one change that matters to me times the hundreds or thousands of participants leads to a kind of quality and innovation that is simply not present in the world of proprietary software. And I'll show you why that matters. It's quality. So typical proprietary software has 20 to 30 defects per 1,000 source lines of code. When I meet with executives at the Pentagon, I tell them that this is a little bit like a good news, bad news story. The good news is you have a battalion of 1,000 soldiers. The bad news is 20 to 30 are insurgents. Okay? That ratio is actually worse than the asymmetric warfare ratio that we're fighting right now. Okay? That's baseline average proprietary software. Now, if you happen to have 5.7 million lines of this average quality code, you would expect hiding in that code was somewhere between 114 and 171,000 defects. Now, the Linux kernel in 2004 was 5.7 million lines of code, but it did not have more than 100,000 defects. In fact, it had fewer than 1,000. One of the really big differences between more than 100,000 and fewer than 1,000 is that more than 100,000 is hopeless to fix. You might have heard of Vista, which had a few bugs. once there's a certain number of bugs, and Fred Brooks wrote about this in the Mythical Man Month, once you go past a certain critical region, you're better off throwing it away. But with fewer than 1,000 defects, these were able to easily be partitioned, solved, and in fact, 100% of these defects judged serious were fixed within 6 months. The next year, although the Linux kernel complexity increased, code defect density decreased, which means that we are in no danger of running even close to that do not exceed line that the proprietary software industry has largely crossed. Now in 2006, people basically said, well, maybe the Linux community is an outlier, and it would be better to ignore that data as some form of statistical noise. Maybe Linus Torvalds is so off the chart smart that we will do more damage to ourselves by trying to understand that level of intelligence than trying to replicate it. So they looked at 32 other projects, and what they found was that some of the projects comport very well with Linux kernel quality. Some of them were not quite as good, but on average, 0.434 defects per 1,000 lines of code is 40 to 60 times better than your average proprietary software. If you look at the LAMP stack, Linux, Apache, MySQL, and PHP, the worst performer of those 4 components was PHP, less than half a defect per 1,000 lines of code. The Department of Homeland Security took some interest in this, and they ran a survey across 250 open source projects comprising 55 million lines of code, and they found that the average defect density was down to 0.33. And PHP was one of 11 projects to have 0 automatically detectable defects. So imagine, you get this report in 2006 that says you have less than half a defect per 1,000 lines of code. If you take the good enough approach, you say, hey boss, we're 40 times better than the industry. Let's go home. If you take that, improve the product and service constantly and forever, you fix them all. And you get this perfect report. In 2009, 36 projects joined that list of projects that had no automatically detectable defects. In 2010, Accenture presented their 5th survey of enterprise software use. Now, Accenture tends to work with very conservative companies, somewhat slow-moving companies. And for 4 years in a row, really the significant reason that people used open source software was that it was cheaper than proprietary software. But in 2010, cost was only the 5th most important factor to these customers. The number 1 factor was quality compared with proprietary programs. So not only do you get cheaper, but you get tremendously, tremendously better. Remember, 18% of all IT applications being abandoned before they go into production, 55% are either late or broken or missing key functionality. If you were to drill into why might so many applications be abandoned, why might so many be challenged, do you think quality would have anything to do with that? Do you think that 100 times better quality might actually improve the chances that that application does get deployed, that it gets deployed on time? Of course. And that is, I think, one of the reasons why things are going so well. So here we get to the punchline of the sustainability talk. Gandhi gave us this wonderful quote, "Whatever you do will be insignificant, but it is very important that you do it." This is a picture of a resonant pendulum at the at the Exploratorium in San Francisco. And it's a 400-pound pendulum suspended from a ceiling 60 feet high, has a 1/4-inch steel plate around it, and you can just barely see the string that this girl is holding on to. She's throwing a little refrigerator magnet tied to the string, which, if it doesn't bounce off the steel plate, which it's likely to do because the magnet is so weak, it sticks on, and the objective is to get that pendulum swinging, all the way to one side and then all the way to the other side. So I took my daughter when she was about this age. After a couple of tries, she gets the magnet on the steel, gives it a smart tug, the magnet flies right off, and she says, "Daddy, it's broken, let's go." And I say, well, let me try. And I get, it takes me a couple of tries. I get my magnet on. And I give the magnet more of a thought than a tug. And then I do it again. Really, really insignificant force. But I begin to think, I see what the pendulum's trying to do, and I start to work with it. And after 5 or 10 minutes, that pendulum is going back and forth so far that the magnet flies off because the string isn't long enough. Okay? Resonance is nature's amplifier. And when you have an equation that allows you to incrementally add energy to that resonant equation, even these insignificant contributions of developer number 388 can amplify and magnify to solve problems unimaginable to be solved using, brute force and sheer ignorance. And so what I have learned in my travels is that, those are just some backups in there, but what I have learned in my travels is that it is far better to make a sustainable solution successful than it is to try to make something that looks successful sustainable. It is much better to architect around some kind of self-reinforcing equation and then make that work. So what Red Hat has done with Fedora, for example, is we don't do it religiously, we do it pragmatically. We work with that community in that resonant pendulum, and we give everybody a feeling of value when they contribute. They actually generate it for themselves. And the result of that is a lot of voltage on that outer coil that then comes in and helps us build a position which would be unimaginable for a company our size. When you look at how big Red Hat is, we keep trying to make it bigger. We're hiring as fast as we can, but we are tiny compared to our competitors, and yet from a competitive position, as you saw in that graph, right up there at the top. And it's because I think we have architected around sustainability, and part of that sustainability is adequate freedom, part of that is community, part of that is liberal distribution. But at the core, it is this self-reinforcing equation that we follow. So thank you very much, and I'll take questions until it's time to go drink punch and eat cookies. Anyone want to throw out a question or two? Yes, sir.
I would imagine that one of the common objections there to doing open source, like if you're starting from a model that's largely proprietary, is that, well, we can't be altruistic with our software. We've got to make money somewhere. So, this thing is great. We can't just give it away. So how do you encourage open source from a mindset like that?
That's a great question. So I'll repeat it for the camera. So basically, if you have started with the proprietary way, it must be awfully difficult to transition to open source because there's a presumption of value in that which is being restricted. And there's also this question of how do you go and make money? And answering the money equation was definitely my co-founder's big mistake when we looked at Red Hat. We failed to comprehend the larger market, the larger potential that Red Hat represented. Had I understood the value of being able to really broadly engage the whole world, compiler tools is a very, very limited market compared to a universal operating system. And so, one way of, so even though we were steeped in the open source mindset at Cygnus, what we just simply could not perceive is how does the world change when you engage it, 3 orders of magnitude differently. And so there are a lot of companies who cannot make that kind of leap, but now is the time for people to do great things. And I would basically say that if it's too hard to see how you make money, maybe you need to set a larger goal. And if you set a goal that is sufficiently large. My signature has a little tagline. It says, "Dream so big you can share." But I also think that, if you don't set a goal that is impossible to achieve within your own current business model, you're not thinking big enough. Okay, one more question?
So my question was, obviously when you're doing open source software, a lot of the people that are developing are obviously customers or like other people who are outside the company. Do you feel like that's almost a commodity that's going to, if a lot of companies go to open source, that commodity will kind of deplete itself and there'll be less people to develop for other companies?
Yeah, so the question basically is it really sustainable?
If everybody does it.
And I believe that we have a whole lot of problems to go solve. Just in terms of a super short-term goal, if we could go from a $3.5 trillion value deficit to maybe just a $1 trillion value deficit, we're doing okay. I mean, we don't even know what would happen if software delivered a net positive impact to society. Right? We just know what life is like when it's sucking 3.5 trillion out. And so I'm very, very optimistic that if we got everybody as engaged as they possibly could be, that people will become even more engaged in what they do and will be more successful at solving the particular problems that they want to solve. So thank you very much.